specialist and director for NVIDIA. He knows both business side and technical side. He published more than 100 scientific papers. And his presentation today is cloud computing, the future of manufacturing and design.
Right, thank you very much. I guess you guys can hear me without the mic, right? I would like to thank Novatte for inviting me over here to talk about our latest products and also to show what are the things that we can do. I think most of you would know NVIDIA in one way or another. If those of you who have children or those who are much younger than me and play a lot of games, you know what NVIDIA is. Majority of our business and the success of NVIDIA has been coming from that. However, over the years, the company has evolved and we are making a lot of business, a lot of new businesses and other stuff that has come out from NVIDIA. So NVIDIA is not just a company that produces games, but also a company that produces high-performance computer, mobile devices, and last but not least is the cloud computing stuff. But one of the very important things that I think all of us would know is that NVIDIA produces what we call a GPU. We are seen as a company that produces things that is visual. It's a visual computing company. So one of the things is that we actually, like I said before, we actually produce technology that is one single technology that's spread across different products. From your gaming cards that you've seen, to high-end visualizations, to high-performance computing, and now in the areas of cloud. So there are various products, and all these various products or whatsoever actually come from just a single technology. It's called the GPU. Right. So one of the things that I want to start off before I go on to the cloud is that I want to show you some of the very interesting things that the company has been working on with some of our partners. And this is a company that we work with called Z-Space, and this is what we see going forward in the future of design and engineering. As you see over here, this is basically a 3D holographic types of design. At the moment right now, it is still not as easy to use as it seems to be, but this is what a lot of people have been asking for. When you design something, you want it to be in 3D manner and able to sort of have it view on the depths, and the colors, and of course the other perspective of it. Now, one of the most important things, one of the things over a couple of years, and over the last few years, we all know that the mobile devices is growing, right? Most of you are either doing emails on your mobile phone. There are still some of us who carry laptops around that do emails with our laptop once in a while. And many times you are on the bus or sometimes in the toilets, in the bathroom, doing your emails on your mobile phones and so forth. So the mobile phones and tablets is growing tremendously. We all know that, as you see over here, this is some of the statistics that have been collected from IDC. You see that mobile phones and tablets are growing tremendously versus what the PC is. And this is another view of it where the Windows and Androids and the Apple's operating systems, the market share of it has grown. You see that Android has grown tremendously, especially on the mobile phones and tablets. So we do know that these devices is become pervasive. The question right now is that it is equipment just simply for you to answer email, or is it going to be an enterprise devices. Right? Now we all know that the application on the phone, there are various applications on the phone from tracking, using it as a GPS, to finding the best restaurant around, finding hotels and whatever, to watching videos. There are various applications. And people begin to start to use some of these applications such as doing banking. So you have become more secure. It has become enterprise level. Now some of us are using it for our company, within our company. The company needs to have it in a more secure manner. But at the same time, we have a lot of huge data. Data that within the companies that needs to actually analyze them or to see them. So these are the examples of it. So sorry for not being very clear about this. But the visual combinations of us is very important. We see visual things, we understand stuff visually easier than we just see a whole bunch of numbers. And this is an important aspect of it. One example of this is basically a oil and gas where they are doing geographical survey, understanding what is in depth inside there. And what they have is that this is a terabytes of data where they are actually walk through into it, understand what is going on within the principle. So visual part of it is pretty important. Now, one of the things is that what we want to do is in the medical areas. And this is what nowadays what the doctors want to do is to be able to actually visualize having the data of the human being, of the person that started doing all the MRI scans, all the data that have been collected. The doctors were able to walk around with a tablet or with a notebook, a tablet, or any other much lighter devices, right? That's able to analyze them and walk around looking at the data and so forth. So these are some of the very interesting applications that we want to see. Another example of this is this, and we have seen this on just now what we see that is on a workstation, and this is examples on the tablets. And you see over here is that it's already people developing applications where the engineers, where the doctors or the scientists who actually visualize are able to go through layers and layers of huge amount of data on a tablet, right? Now, when you're doing it on the tablets, what is it that you need? You can't store a lot of data. How much can tablets store? 64 gigabytes of storage on the tablets at the moment right now. Maybe 1 to 8 going into the future, 256 maybe in a few years time, but it still can't store a lot of data. We are talking about this in terms of hundreds of gigabytes of data that the doctors able to move in and out and watch it very carefully. So this is one application of it. Another application is that, for example, this is another example where the engineers and scientists, or rather basically the engineers, were able to do a GIS, right? Going to the site, able to look at geographical images, geographical information that's allowed them to do a lot of this analysis. So these are some of the examples of it. So what we need to do, cloud computing been around for a long time. How do we then integrate the graphics part of it into this? Because the easiest part of for us understanding any of the data is actually graphics. So one of the things is VDI, right? Or virtual desktop. And the thing is that this idea has been around for a long time. This is not new. It's been around for a long time. The question right at the point in time was that technology was not able to deliver. One of the things was that the server, the graphics and the server is not able to deliver the kind of pixelizations for the end to render fast enough. The other one is of course the network. And both of this technology has been moving tremendously fast. Well, network right nowadays, pretty good network if not for once a while there's a breakdown in Singapore. But other than that, basically part of the network itself is pretty impressive, I must say. So the VDI start of it is that there are this survey asking that why do we need actually companies is looking at doing VDI. There's a huge amount of interest right now in people looking at VDI. And there's a couple of them. They want to support employees to work anywhere. Maybe this is something that Singapore is really evolving into. I myself has been, I hardly work into my office. I work from home, I work from the university, I work from the customer side, I work from the swimming pool, and anywhere else except the office, right? So the company has to somehow support that environment for me. I've got to work anywhere that I want. And then of course, I sort of like, when I don't have to manage, actually they don't manage my PC at all. All the patching, all the thing was done on the server side. Everything was done at the on that end, and I'm not really at the end. So these are some of the things that you could see over here that you could see that why the VDI has become an interest. Now, this is just a chart showing the desktop and laptop growth of it, and I don't want to touch on it too much. But just to do an interesting search on Google itself, and this is what has been doing on Google Trends. As you can see over here, the number of people who are looking at think time style is not really that increasing. But what people are more interested is actually people are looking at all the visual visualizations and also the bring your own device type of things. Because most of us right nowadays, some of the companies, maybe not in Singapore yet, but most of the companies right now, they give money to the employee, buy your own device, and then we will then put you on to the company infrastructure. And there's your own problem right after that, because our company will provide you the necessary. So there are a lot of things that's going on, from video analysis to desktops to showrooms to collaborative design whatsoever. A lot of these things are actually visuals, and how do we actually do all these through what we call a VDI environment. So one of the things is that we use the 3D GPU to accelerate that. One of the things was that there are different class of people. There are people who are doing what we call designers. There are people who are doing what we call power user. And lastly, but not least, last is what we call knowledge worker. Knowledge worker will be a majority of us, from the clerks to the accountant, whatever, where they dealt with basically spreadsheets, PowerPoint slides, word processors, and so forth. And then you have the power user to using things with the more high power. They need a bit of graphics, still not in 10 or whatever. But lastly but not least, is actually the designers. People are doing crude animations. People are doing engineering design work where you bring up the CAD, right? Where you need to interact with it in a very intense form. You require 30 frames per second coming to your screen so that you don't see all the jiggling. You want to, when you click your mouse, you want to rotate the thing in a very quick form, which after that you can see it outside in the demos area. So those are the things that one wants to see. So just let me just show you some of the stuff that's going on, and what is nice to have, and what you must have having a GPU. And this is one of the examples, and you can see outside the demos over here. This is what what you can do without the GPU, and some that you can do with the GPU, right? So many of them, some of the ISP or ISP is something to look at, and the company is in fact very providing is that desktops as a service. Right? So you are bringing in a very thin client, a very piece of tablets or so, and then the company is providing you the environment of the desktops. Think of that environment. So how do we actually go about delivering that? So of course it is basically what we call remote graphics. So we want to deliver graphics itself. Now delivering data to your devices is a very graphics to your devices is not an easy thing. Or rather, once that your device, you do all the graphic stuff, it's not an easy thing because you need very, very powerful GPUs or graphics processors on your tablets or your TV device, and make it hot. Use up a lot of power. You do not want to use a tablet that is every 2 hours you want to charge. You got to charge it. You do not want to do that. And also at the same time, you do not have all the data, all the storage inside of it. So what is in remote graphics it does is that it actually do all the rendering in the GPU itself or in the server. It send out pixel onto your screen. It's just like watching videos. It's just simply pixel, nothing else. Right. So there are a couple of ways. One of them is just simply what we call API intercept, which means that you whatever the programs ask for a graphics API, they will intercept and then will route to the NVIDIA GPU and then process it and then send it back. So there's one way of doing it. Another way of it is what we call pass-through. This is totally dedicated, which means that every time you have a virtual machine, whatever, you will be hooked on to a single GPU itself. And this is pretty good, but it is expensive because the GPU itself, which means that every time there is a virtual machine that hooked on the GPU and logged on to the GPU, then no one else can use it anymore. So that is one thing. But they are very impressive because they give you a lot of capability, which I can actually show it to you over here in the demos. Right. This is just a simple comparison of it, video of it. So this is traditional VDI. Backend is just simply rendered by the CPU, and over here is rendered by the GPU itself. As you can see, this is Google Earth. So as you can see, is that it's able to render very quickly, send on pixel, and so forth. Now, the reason why you can do it so fast is because behind it, you are talking about a GPU with 2,000 cores doing all the necessary renderings, right? And then just pixelize and send it across the. So the enterprise, the next generation of enterprise virtualization is no more just virtualizations per se, but we also need to virtualize the GPU. And that's where NVIDIA actually comes in together with our partner here that we're going to launch our products to talk about the new technology that we are talking about. Basically, the ability to actually virtualize the GPU. So GPU itself, in the previous case, where you can think of it, is that GPU is like a card that when you have a VM, it's dedicated. When you have operating system, it's totally the operating system will put on over the GPU, and no one else can use it, right? Except for that either the virtual machines or that particular operating system. Now the GPU is so huge. We're talking about 2,000 cores. In the future, going forward, it's going to be increased number of cores. So what we have done is that now we have actually re-architected our underlying software layers, and also with the new GPU, what we call the capital, allows people to have actually multiple channels, people to actually able to virtualize it, to cut the GPU into pieces, and then each virtual machine will use part of the GPU, and that is the thing, right? Now, afterwards, you will see more of these demos outside there, where Yuri and his team will actually demos. But I just wanted to show it to you over here that this is basically one of the PCC, and these are examples of using the K1, K2 together with Citrix and so forth. This is the desktop machine, and this is very, very useful for people. Just imagine that in an engineering firm, right, you have a lot of people with very high end workstations. You could then have servers having produced this kind of capability to your designer. The designer will be able to bring in any kind of devices or a low-end workstation or server, and then do the necessary work. And all these things is done over in the background. Second thing is that it's secure. Because now you have total control of the server. Data is not on the workstation itself. Data is on the server. So these are some of the things that you can see. Now, when you go out in the demo site, you will be able to see more of this. So we have things we like, there are the various options you can use. depends on the operating system, depends on things. So the ARM, what we call the vGPU, you will hear a lot of terms about this. That you're able to virtualize it, and then each virtual system cell able to use half of the GPU. Right. So there are leading applications which we see outside that. Things like Photoshop, OS, and so forth. There are a lot more things. So these are finally that comes to what we call the product side. There is this product called the K1 and K2. Don't worry about the name. I myself are always confused by marketing people about the name of it. So don't worry about it, because at the end of it, the important thing is that you know that the capital GPU can be virtualized. So that's the most important thing. And then just bring up your checkbook and write a check to you to buy something. But the thing is that these are some of the products that's able you to that I explained to you that able to do virtualization of these graphics. So if you look at it, there is this K1, which consists of 4 capital GPU. There are 4 GPU of it, but there are smaller number of cores per GPU. On the other side, the high-end capital with a big GPU of it, it consists of about 1,500 core per GPU. So you see that the power consumption is slightly higher. So it depends upon the applications. Like in the next slide itself, you will see that it depends on the applications. You will want what sort of products fits into your usage. So these are some of the stuff. Now the slides we make a little to do. Let me just run through this very quickly. So again, graphics are dedicated to the GPU. They are depends, like I said, it depends on the applications, depends upon the number of CCU you choose, type of cards that one wants to use. So this slide is basically same thing on whether you're using chips, graphics, or dedicated graphics, or graphics with GPU, and each of them actually what they do requirement for. One of the things that we have a quote from this info world is that as you can see over here, that having such technology, 3D graphics technology, while vGPU, is basically one of the holy grails that people have been looking on for many years. Like I said before, the VDI is not a new concept, right? It's just the technology was not able to do for a long period of time. I was working for FGI many years ago, and at the point in time, we were designing the systems for such applications. However, for those who have used FGI machine before, you know that FGI Onyx machine easily costs you $500,000 to $1 million, right? One RAM mod, which is now costs you less than maybe it's part of the GPU graphics card, costs you maybe 100K to 200K. Depends upon capability. Now, with the GPU card itself, just costs you a few $1,000s. So the technology and the price point actually come down. The technology has improved and the price point has come down tremendously. So NVIDIA Bricks is basically designed for enterprise virtualizations. As you see over here, takeaway point is that, and Yuri is going to explain more about how to work together with NVIDIA to produce their products, totally integrated stacks of it. It's going to be very interesting of it. And then you will do full PC virtualization. Almost what we want to do is that almost everyone, everywhere, and almost on any device. Right? Now, one of the things before I want to walk away, this is going to be my last few slides. I've a bit accelerated my talk a little bit. Is that I want to do this. Is that there is an explosive growth of GPU usage over the years. So whether it's for virtualization, whether it's for compute or visualization, it has been a tremendous amount of people have been using it nowadays. So in the year 2007, where we start to introduce and evangelize our GPU, there was this statistics that you can see over here. And over the years now, you will see that there is a number of GPU that's being used. Whether is it in NVIDIA systems, whether is it in your incline, notebook, tablets, or in the high performance computer, it has grown tremendously. One of the things is that we are encouraging a lot of universities to actually take up, we have actually courses for the universities to teach what we call CUDA courses. That is, which is the environment for programming GPU running that in parallel. So one of the things is that the era of accelerated computing is here. You will see that machines are getting bigger and bigger, and not just about high performance computing itself, you also have cloud computing, so to say. So with that, I'm going to end my presentations, and these are some of the resources that you guys can actually go through. The usual suspect, from Twitter to YouTube, Facebook, and also, and by the way, I heard that Twitter has been IPO for 36 months, right? And those guys can make a lot of money. But anyway, these are the information that you could actually get. And for those who are interested or whatever needs to, send me an email, and we will discuss about possibility of putting together either to Yuri or to myself. So thank you very much.
Thank you, Simon. I would like to invite the audience, in case you have any questions, to ask Simon about this interesting presentation. I have some free goods to incentivize you, so to incentivize the most active listeners.
Also about the client side and the server side, but did you do anything in this NVIDIA grid to solve the network latency issue between the client and the server? Because I would think that would be the major one.
Yes. So the thing is that we can't do anything to solve the network latency. Network is not
Workaround.
Yeah, it is. We have to talk to people like Cisco, Huawei, or whatever, and they will be the one having to solve the part of it. What NVIDIA do is just simply is to able to render things in the GPU itself and send out everything up to pixel, and then have the underlying layers that allow you to actually interact with the backend servers very quickly. But at the end of it, you're right. The end of it is that the network itself is the bottleneck to the latency. If the network if the network is bad, the technology is not useful. Right? So we are still choked by the network. But in some places, for example, within Singapore itself, of course Singapore going to somewhere else, that's a different story. But within Singapore itself, it's still fine. I have done some of the demos that connected to the US. When we have only 2 or 3 hops, it's still fine. But sometimes the routing machine is not that good, right? The routing machine, just to go over to Malaysia, give me 6 hops, or even sometimes 10 hops. And that is not a good thing. So we have to somehow work with the ISP to see whether can we actually reduce the number of hops to the necessary site that we want to go to.
But there's no special compression or...
Oh, there's compression, everything is done, there's done to that. So you have to reduce the bandwidth. But latency, I can do a lot with bandwidth. I can't do anything with latency. And that is, unfortunately, that's physics.
So how will this work in a 3G? You mentioned tablets, for instance, in a 3G mobile environment.
Oh yes, we have done some of this. If you on the mobile devices, especially on a phone or other things, if the network is good, it's pretty nice. I mean, you get maybe about 20 frames, 25 frames. It's still pretty comfortable. But again, 3G depends on who is the provider. When I was in China, the 3G wasn't what we suspect to be the 3G, right? And I couldn't do the proper demos as I would like to.
Any more questions?
Could you explain a little bit more in detail about how your products interact in the virtual machine and which virtual machine stacks you're supporting? In particular, the Linux versions of software.
Okay, so I think Yuri is going to talk about it afterwards. So just to be clear on that, at the moment right now, the leader of this in terms of this VDI is actually Citrix, right? So we work very closely with Citrix itself to do that. Of course, we also work with the other vendors, but at the moment now, the leader is Citrix. But we can take offline. I can take offline view to give you more details about how the interface between our product, our technology, what we call Montre, together with the Citrix virtual machines. Questions?
Do you have any questions?
Other than Citrix, do you have anything for Apple open source? Do you have anything Apple in open source?
We always rely on open source to actually how they want to work with us, right? The Citrix is at the moment now is the leader in this, like I said before. They are very aggressive in moving this technology. So they come together with NVIDIA to enable their VDI, because to them that this is a big area they are focusing on. The open source question of open source, that is something where we will have to leave it to the open source community to address that. Because some of the API is actually open. It's up to them actually to actually adopt it. Right. They are on the pass through, but not on the. So just to be clear, there are already some open source working on the pass through, but not on the virtual machines, virtual GPU yet. Any more questions?
Okay, just in case you will have additional questions, you can find.
Yeah, you know where to find it.
Yeah, you know where to find Simon, because we'll have a small debrief after the second presentation. And for the second presentation, I would like to introduce the second speaker, Yuri Drozdov from Novatte. He's our chief executive officer, and I can say that he is a very passionate person, and he is mostly passionate in diamond and fast cars, and I believe that his passion transformed in passion for very fast supercomputers. So Yuri will explain us and give us more details about what kind of supercomputers Novatte creates, and more details about mostly how in real life NVIDIA grid works.
Thank you very much. I will also talk without the mic here. Basically, what I want to urge you, if you do have a question, please raise your hand and we can discuss it in just a conversational manner. So I don't want to keep you very formal. So thank you very much for Simon. He gave us a very nice introduction of what NVIDIA grid technology is. And I would like a little bit to discuss the reasons for the remote graphics and why we personally do care about it and why people should care about it together with us. And later on in one, we will show you some demos here. And we have some booths over there, so you can see some of the applications that usually run any super workstations with K4000 to 5000 graphics. They can be pretty much easily run through the Wi-Fi. So, for the way for the last several years, the way how we work, during the past few years, the way how we work has changed. We don't sit at our desks anymore. As a result, we bring whatever computer we have to work. And they call it buy or bring your own device. Some people call it consumerization of IT. But a relatively easy concept to understand what it is the following. Back in the old good days, we used to have a company cars. Who gets the company car now? Right? So So back in the old days, we used to have company computers, as you can see here. But it's almost ridiculous to get the one in the future. Because by the time you come to your office, you already have a computer. So why do you have to use two computers? Why don't you want to just use the computer you already have? So bring your own device. Consumerization of IT. We also know that the data is getting larger and larger. The architecture of the personal computer and how we do set up our corporate networks is related to the type of work we were doing. It made more sense recently to take the data from the network server, to download it to your local client, to keep it in a swap space, they call it swap space on the local client, dig on it, perform some jobs, and later on to download the result back to the server. So you have a copy of this data, right? The server can have a copy of this data, I have a copy of this data, everybody has a copy of this data. The idea is it's a direct opposite of staying in C. Well, today the data is so big that we have frequent customers who it takes around several hours to download the data from where the location this data is to their local office, to dig on it, to work with it, and then spend again several hours to download it back. By the time actually the data moves again to where it resides, the local team has already changed the data. So data is becoming so large, whether you design chem data or whether you design media data. And it makes not more sense to download the data to the computer. On the other hand, it makes more sense to move PC to the data. So notice cloud computing. For example, the small little thing called Shazam. This is the music identification service. I'm not sure whether you use it or not. You have the small application of your mobile phone. You touch it when you hear the music. Later on, this data is sent to the server, and later on, you get the reply who is playing this music. So this won't be available, and this won't be possible without the cloud computing. And today, mobile computing is affected by the large data, and the way that we work will affect the architecture of the enterprise, the future enterprise. So today we are presenting the technology which will change the world, how it looks at computing. The virtual GPU technology, which is enabling new architectures of the enterprise. The new enterprise, which is data, is actually residing on the server, in the server. The computing is done in the server. But because we can process this data so fast and transfer it to the pixels, that you think that the data is processed on your local desktop, which is just virtual behind you. But at the same time, there are lots of small and medium sized businesses and universities who design light gadgets, create commercials, who act as outsourcing partners to large organizations. They're creating parts of movie, creating different, teaching different CAD courses over the network, over the internet, and so on and so forth. There are small and mid-sized businesses who doesn't have the IT support, a huge IT department. They don't have the enterprise server. They just buy their laptops and computers at the Apple store or another computer store. But the computational problems and challenges they are just like the ones that I have explained earlier for the enterprises. They would like to be remote, to work remotely, to be heterogeneous, to be able to work from anywhere, to be able to share the work on the basic and work on the basic database without having synchronizing and copying the data all over the place. And of course, security is a huge concern because sometimes, or even for some companies, most of the time, the work with the data it just doesn't belong to them. For example, movie companies or CAD design companies, because the data belongs to the corporations that outsource and work for them. So security is a huge concern for them. But think about it. What if you have tens of workstations or hundreds of workstations? You have people here who have hundreds of workstations, which were purchased through the last 5 or 7 years. They all have different They have different operating systems in them. They have different applications with, again, different versions of software in them. This is a software nightmare. This is the paramount of the software nightmare. What if we put that into cloud? But you need to have a remote control to do it immediately, right? When you switch the television channel, you would like to have it immediately, not tomorrow, right? So how do we do that? What if you are a small and medium-sized business and you want to work in a modern way without the support of large IT department? You want to have the ability to collaborate. Just, walk away from your desk, bring all your stuff together with you, sit with some group in a room or even in another office and discuss your design, review your design, share with other people, argue with them to make the design better, how to make the design better. How do you do that today? We believe that this environment needs, what these work areas need, what these customers need, the way how they do their work, the problems they would want to solve. It's not the large rack of enterprise service. It's much more easy and simpler than that. We call it NovaTte, visual computing appliance. It's not the server, it's the complete system, the end-to-end system. All the software is already integrated in it. The entire experience is already integrated in it. So it's a real visual computer appliance. NovaTte is 2 units in height. You can actually see it over there in the corner. You fit it in the rack. Inside there are 2 highest performance Xeon processors with 16 threads each, and they're all connected to the 256 gigabytes of memory, system memory. It also has 3 GPUs inside, K2 GPUs, if you remember Simon's slides before. And each K2 card has 2 Quadro K5000 GPUs in it. The most advanced Kepler GPU, which is a level of the market. And everything, all of that is integrated just in one single appliance. It's a little bit like a router or network storage. You buy the box and it comes all with a pre-installed software and it's already working. You have a hypervisor, it supports up to 6 virtual machines in it. And these 6 virtual machines can be connected to 6 different devices. In fact, you can connect as many virtual machines to one device as possible, as you want. We will show it to you in a minute. And each of the devices simply needs to download and install very thin application like VPN application. You just pump it in and it starts working. So there is a way how NovaTte works. It's get connected to your small group network. So as many people as you have can be connected to it. All you need is to have the tiny little client on your existing machine or laptop, which I just spoke recently, like VPN. You pop up on it, and you get the virtual remote, fully GPU accelerated workspace. It's just showed up. So this particular company, they have in office 18 people, and they are all having powerful Quadro K5000 workstation on their desk with a NovaTte. And it doesn't really matter what front-end computer they are using. It can be Mac, it can be Linux, it can be Windows. It actually can be even a Android thin client. So we have tested MATLAB running on iPad in our office, so it was working pretty fine. The computer at the back runs the application. It's not the computer in front which is doing all the calculations. The computer at the back runs the application. And what we see on the front-end devices like laptops or thin clients is just the pixels, the rendered pixels which are thrown in through the network. So all these users of the network, they all have their own personal super workstation with a Quadro K5000, not dependent on the front-end device they are using. So we would like to show you a little bit how the system works just here, so you can feel it a little bit. So I would like to call my colleague Roman, who will be doing the demo. Just a second. If you do have any questions for now, please ask them while actually connecting to the mirror.